So this is the second lecture for CBSE 12th standard. To find the magnetic field due to a current carrying conductor. Okay, so this conductor is a long straight conductor. Okay, I is flowing from bottom to top. It is infinitely upward, moving up. So it is infinite long, right? So I have to find out the this B at this point P due to this conductor. So as I told you, whenever we want to find out B due to the current carrying conductor, then I have to use Biot-Savart law, right? In Biot-Savart law, we have ideal cross R, right? So ideal is one vector which is along I, okay, in the direction of I, and this is the unit vector R cap, ideal cross R cap. Okay, this unit vector will be from the source to the point, where I want to find out the magnetic field, right? So the source, I am splitting this whole conductor into small element. Okay, so one such element I am taking here. It is very small, but just to make it understand properly, I am just magnifying it. Okay, this ideal is very small. This is your ideal vector. Okay, so it is along I. See, ideal. So from here I will do some extra constructions. So from P I will drop a perpendicular here on this conductor. Okay, this is your perpendicular. This distance, let it be R, and here this is L. Okay, at L distance I am taking this ideal current element. Okay, then I will join this. To P. Okay, P is here. Fine. And I will name this vector as R vector. It is directed from source to the point at which I want to find out the B, isn't it? Here I need to find out B is equal to what? Question mark. This only we have to find out, right? So if this is R, then unit vector will also be like this. R cap will also be in this direction, isn't it? The magnitude is 1. And because cross product, in order to find the cross product, we need to know the angle between ideal and the R, isn't it? Because I want to find out the cross product of this. So this is theta. This angle is theta I am taking. So now let us use the Biot-Savart law. Using Biot-Savart law, what we get, because this is a small element I am taking, so due to this small element I will be getting a small field here, right? So that will be dB. I am naming it as dB. dB is equal to, I am taking the magnitude alone. Okay, direction we'll discuss later. So mu naught by 4 pi mod of ideal cross R cap divided by R square. Okay, so mu naught by 4 pi, ideal is ideal, for R cap this is 1, isn't it? Magnitude of R cap is 1 and angle between them is sin theta, so sin theta divided by R square. Okay, now we will find out the value of sin theta. So sin theta is equal to what? Look here, if this is theta, this will be how much? 180 minus of theta, right? 180 minus of theta. So sin theta is equal to sin 180 minus of theta. Sin theta is equal to sin 180 minus of theta, right? Sin 180 minus of theta. Sin 180 minus of theta is what? Opposite by hypotenuse. Opposite is what? Opposite is your R. Hypotenuse is your this R, small r, right? Now this small r also we have L square plus of R square, isn't it? The small r is also root over r square plus of L square. Okay. So now let us write this value here. So dB is equal to mu naught by 4 pi I dl divided by r square is r square plus of L square into sin theta is what? R divided by root over r square plus of L square. So mu naught by 4 pi I r divided by r square plus of L square raised to the power 3 by 2 into dl, right? This is what we are getting due to this ideal. Here we are getting this dB. This is the dB, right? This is equation number 1. Now you see, because it is infinitely long, right? So from here the up portion and from here the bottom portion, if I split it in small part, you see equal length at equal distance I am taking one more ideal here. One more ideal here I am taking, okay, at the same distance L. So this direction will also be like this, right? Ideal. This vector will be this. And if I join this, it will become one isosceles triangle, right? Right, isosceles triangle. This length is equal to this length. So if this is 180 minus of theta, this angle will also be 180 minus of theta, right? Am I right? And due to this also, if you see ideal cross r, this is your r, right? The magnitude of both will be same, whatever, because the sin theta is same, no? Here magnitude depends upon the sin theta, right? From here you see sin theta, because ideal is ideal, r cap is 1, r cap is 1, and it depending on sin theta. Here sin theta is sin theta, for this also sin theta. So the value of dB will be here same, right? So what I can do, I can integrate just this portion from here till up till end, okay? I will go like this. So that will be, the total B will be what? The bottom portion plus of top portion. So total B we are getting it as 2 times of integral dB, right? And from where to where? Theta is from 0 to pi. 0 to pi by 2, in fact, not pi, 0 to pi by 2, right? It will go like this, 0 to pi by 2, correct? Okay, fine. So let me, here the space is less, I'll write here, yeah. Now, quick. B is equal to 2 times of, you take the constant out, mu naught by 4 pi I, r is constant, right? R is constant, so take it out, 0 to pi by 2, right? 0 to pi by 2, 1 divided by r square plus of L square raised to power 3 by 2 dl, right? So we need to integrate it. So put L is equal to r tan theta, right? L is equal to r. So dl is equal to what? R secant square theta d theta, and take the angles now. This is your L and this is your theta. When L tends to, when L is 0, theta is also 0. When L is infinity, going like this, isn't it? When L is infinity, this don't take, this is your infinity, right? When L is infinity, this is pi by 2, right? From here we are going to infinity, means from L length, no, from L length, from 0 length I am going towards infinity, and as far as angle is concerned, from 0 to I am going to pi by 2, isn't it? 0 to pi by 2, 0 to pi by 2. So B is equal to B is equal to mu naught by 2 pi IR 0 to pi by 2, dl is r secant square theta d theta, right, divided by r square plus of L square. L square is r square tan square theta, right, tan square theta. Fine. Okay. So this is mu 0 by 2 pi I r square, and bottom also I r square. This is 3 by 2, right, 3 by 2. R square, if it comes out, it is r cube, right. So 0 to pi by 2 secant square theta divided by 1 plus tan square theta is again secant square theta. So ultimately you will be getting secant cube theta and d theta. Hope you know the integration. So this gives me mu 0 by 2 pi I by r, okay, I by r 0 to pi by 2, 1 by secant theta is nothing but cos theta d theta, right, okay, cos theta d theta. So mu 0 by 2 pi I by r, cos theta is minus sin theta, no, cos theta is sin theta only, cos theta is sin theta, 0 to pi by 2, right. So this gives me mu 0 by 2 pi I by r 1 minus of 0. So what you are getting ultimately, B is equal to mu 0 by 2 pi I divided by r. So this is the magnetic field due to that this long conductor at point B at a distance of r from it. Okay, distance means what? So from a straight line, if you want to find out the distance, you have to write the perpendicular distance, right? So that is the r. Fine. So this is what the magnetic field we are getting at point P. Okay. Yes. Thank you. Hope you have understood it. If you have any doubt, you can write me in your comment. Okay. Thank you.